Yeah, I think we can start, the session. Thanks, first of all, to all of you for joining the session. I will be the moderator of this session. I'm Espedito Rusciano. I work for the JRC, not here in ISPRA, but in Petten, as a program manager for the scientific research. Mainly my focus is on automated driving system. The current panel session will be on artificial intelligence on connected automated driving. The title is, and I hope that the technology will work, but otherwise, let's go to the next slide. Yeah, sorry, but the clicker is not working.
It's working, it's just on the top right, not there.
Okay. Yeah, I think this is not the right presentation. No, you should, display the full the presentation with all the slides. This is, the slide from German. Yeah, sorry for the problems. Yeah, I think you need to change there is, one. You need to change because there is the presentation is the. Yeah, let me. Okay, perfect. Now, understood. Okay, sorry for the problem. I was saying the presentation, the panel session is called AI for Connected Automated Driving, from enabling technology to trustworthy enabling technology. I think we are all aware that artificial intelligence is the enabling technology for allowing automated driving system, or CCAM, on the road. It's already used, for several applications, I would say for several functions. If you look, for instance, to the perception part or to the planning part, but also if we go a little bit, beyond, if we look to the V2X communication, the cooperative driving, already we have artificial intelligence, even if we think about human-machine interaction. So I would say that artificial intelligence can be considered as the brain behind a CCAM system that will enable to have a system that will be faster and smarter. At the same time, artificial intelligence is also raising, I would say, a lot of questions and also a lot of challenges. Let me just mention, a few of them. If we look, for instance, to the technical challenges, there are a lot of aspects. For instance, let me say just, the explainability is one of the open points. And we will discuss today if we need and how to achieve the explainability with AI, but also how the AI will react, for instance, to unpredictable situations. There are a lot of questions from technical point of view, but also there are other aspects, for instance, about the data, how we can ensure the quality of the data and also the diversity of the data set. This is one of the problems. But going a little bit beyond, if we look also to the cybersecurity, how we can ensure that AI will be able, to manage cyber attack, and also how we can ensure the privacy part. And moving a little bit more to the regulation aspect, how we can ensure the compliance to the current regulation. Let me think about, for instance, the AI Act at European level, but also what is coming at international level. So there are a lot of open points. And also we need to think on the fact that the current AI system should interact safely with the mixed traffic, with the diversity of road users. This is another aspect. And finally, I think it's also important to take into consideration the interoperability aspect, the fact that we should ensure that this system will be able to work in the different regions in a way that will be that will make them, interoperable. In particular, if we look also to the communication part. This is the reason why we decided, to come up with this section. What are the objectives of today? Mainly, we will discuss on the role of the AI, with focus on the validation part. Mainly, the focus will be the explainability, but we will try to touch also other aspects. And then we'll move to the regulation. also trying to touch topics like ethical, even though the focus will be mainly on the safety part. For doing that, it was important for us to involve people and stakeholders from different parties. We have representatives from the European institution, from the member state, from the type approval authority, and also from the industry. So, without further delay, let me first introduce the speakers. I would like to start with Sarah. Sarah is the head of the public policy at WAVE. Sarah was also, previously an associate director at Teneo, and she started her career as a senior policy advisor in UK. She has a background also in data analytics, and she has a Master of Science in Chemistry and a PhD in organometallic catalysis from the Imperial College in London. So thanks to Sarah for being here. And then we have Zisis Zakiridis. He's a policy officer at the German Federal Ministry for Digital Transport. He works in the automotive engineering unit, mainly working on vehicle safety and innovative technology. And his focus is, he has a degree in mechanical engineering with a focus on computer science. So thanks also to Zisis for being here. And then moving to the type approval authority. We have Shubham Koyal. He's an advisor at RDW in the Applied Innovation Department. He has a lot of experience in different regulations that are related to artificial intelligence, like the cybersecurity, the software update, and also the EUCAD regulation. And is now working on developing an assessment framework for artificial intelligence. So thanks also to you. And then let's move to the last panelist, that is Alvaro Cabrera Egea. He's a policy officer at the European Commission, DG Connect, in the AI unit, with focus on excellence in AI and robotics. He previously worked as a principal researcher at Fujitsu Research Europe, leading the work on generative AI and AI ethics. He also holds a PhD from the University of Warwick, mainly focusing on reinforcement learning. So thanks to all of you. And then before moving to the topic itself, I would like just to share with you basically how this session will be structured. We will start after this introduction. We will start with a short introduction from all the panelists that will provide their point of view on the topic. And then after that, we will start with some questions. I will be the first to make some questions, and then I will ask also you to make some questions regarding the AI. First of all, we will have some interaction also pool to ask, also to you some questions, and then I will also open Q&A in order to give you the possibility also to ask direct questions to the panelists. But without further delay, I would like to invite, the first person, that is Zisis, to provide, your point of view on the topic of artificial intelligence for connected automated driving. So, Zisis, the floor is yours. Yeah, please go.
Thank you very much. Thank you for the kind introduction. It's a pleasure to be here. I'm now part of the German Ministry for Digital and Transport. And we have many topics in our focus, and one of those is artificial intelligence. So before we start, some general remarks on artificial intelligence. I would say, what is AI? This is quite difficult, and I would like to break it down to some few points which maybe are feasible or maybe touchable to all of you. So maybe you can, especially for those who are not such deep in the topic or don't know, maybe have the expertise what AI is from our point of view, from my point of view. So the first thing is, I would say AI is a tool or a toolbox. So very dedicated tool, like you can imagine as a screwdriver who has a specific task, similar as AI. So you have a defined problem, you know what could be done with AI, and this is very dedicated place what AI is. So second, AI is statistics. So if we know about AI, we know about statistics. So if we are good at statistics, we are good at AI, and the other way around. So always when we talk about AI, it's mainly statistics-based approaches. It's very important to know. Next part is, of course, it's data-driven. So Some of you might know this, garbage in, garbage out. Many data scientists know this issue. So if you have some good data sets, quality of data, quantity of data, AI can be used to have a solution based on this data. And another thing is AI always has system boundaries, defined system boundaries. So similar to comparable to thermodynamics, but also towards ODD, for example. An AI has always some boundaries in the space where this AI system is working. So it's bounded by the boundaries which, for example, the data scientist is putting into the system or into the AI model in a certain way. So this is a first overview what AI is. So let's go to what AI is not from our perspective. So it's not a super intelligence. So the AI is always linked to those aspects, I would say. So a vehicle, for example, will not drive by itself from here to Berlin. This will not happen if it doesn't get the dedicated task to do so. So it's not a self-learning or self-developing product or system. It's always linked to a dedicated task, which the engineer, the data scientist, the company, whoever puts in the system. And also that AI doesn't come with totally new ideas or solutions. It's always linked to the task it's put into the system. And always depending on the data which says. So you have some causalities in the data, and based on this, AI is working. So if the information is underlined in the data, AI can work. If the information is not in the data, AI can do nothing, actually. So let's go now to the next area, and now let's highlight what AI is for the automotive sector, which we are currently in, and why it's important for the automotive sector to focus on the AI also. So we have a direct impact. Many systems are AI-driven, for example, ADAS. So we see an increase of performance and robustness for ADAS systems, quite clear. The systems have a better performance, can solve more solutions, are more robust in testing, for example. Different test approach could be dealt with this AI system. Towards ADS, we talked about this level 4 approach. Enablement of ADS is part where AI is used as a direct impact on those systems through AI for the vehicle sector. We have also energy efficient vehicle hardware, so ECUs, for example, which could use AI to be more efficient. This is a part where we have a direct impact. And we have also the software. So also the software which is put in the vehicle, for example, lines of code, could be dramatically reduced by AI. So AI is a tool to make good solution or compact software solutions also for the vehicle. So we have an indirect impact for the vehicles, which is vehicle safety, for example. So if the systems, like ADAS system, is more performant or more robust, of course, also the vehicle safety is increased because those systems have less failure, perform much better. The vehicle in total is safer. It's important to know. So you don't see this impact directly, but you have some indirect consequences of a good AI system, for example, in ADAS. You have emission, for example, also an indirect. You can, with AI, go to process optimization, for example, and optimize the emission part of the vehicle. Also an indirect impact of AI, which is there. You have customer and travel experience. So AI can make, for example, navigation more smooth. The paths can be better. Trajectories can be optimized. Also, this is an indirect impact because mostly the visitor, the customer just watches the navigation screen and doesn't know what it's underlined, which layer, which AI is working there or might not working there. And also what we see is database business models coming more and more to the vehicle. For example, predictive maintenance, where the AI is making some predictions when, for example, a dedicated or specific part of the vehicle might failure. And this could be used for the manufacturer, but also for other stakeholders like repair places, to make business models based on the data which is in the car, but also around the car. So let's go now to the next slides. What is the gap analysis? So we have different parts. We have standards which are already on the field. Some of them you might know. We have general standards, which is, for example, the ISO 26262, the functional safety standard, which has has some influence on AI in sort of way. We have also another general standard, which is the SOTIF standard. Also there are some general, I'll say, implications, requirements towards AI. And we have more specific standards on the other way, which is, for example, the ISO PAS standard 8800. It was finished in December last year, so it's pretty new. So also there you see some more specific requirements or specific tasks towards the life cycle of an AI model, for example, which is underlying these new standards. And we think what's missing? The gap analysis now, we have some standards, we have also some regulations, like, for example, cybersecurity, 155 is a good example. But even with the standards and the regulations which are in place, in force, and also with some specific standards, still we have a missing part which goes towards how to operationalize AI in a way. So we have, for example, the AI Act, but what does it mean for the vehicle sector directly? What is the requirement? What is the parameterization for those regulations? What type of approval should do? And here we have some gap, which is currently there, and this we should maybe discuss or tackle in the future discussions or in the future work. And now coming to some regulatory challenges which we see in our systems. First, some general ones. So we see, for example, in Germany, we have the Road Traffic Act. There we have some issues about responsibility and liability. So also this discussion goes towards ADS, how reliable is the system, who is in charge, who is not in charge. AI also opens a new area for this discussion towards those national laws, but also regional laws in the case. We have also regulatory challenges towards type approval, which is, of course, the main framework here in Europe. So here is the main challenge, the operationalization of requirements. So we have the AI Act, but it's pretty generic, pretty high leveled in a way. And what does it mean for type approval? So we see some issues there that type approval can't deal directly with this AI Act in Europe, which is now in place in Europe. And we see also the market surveillance. Here we see a big challenge towards traceability and explainability. So AI is in the system, AI is in the car, it's on the streets, something happens. Can we trace it back? What happened? Which system failed? Which model failed? At what level the model, what layer the model failed? And can we explain it? Sometimes yes, sometimes not. Depends on the model. It's not just such easy to tackle this. Depends on the system and on the focus. And coming back to the challenges in the WP29, the World Forum for Harmonization of Vehicle Regulations, a new group started or will start this next month tackling some of those issues. So we have an international forum which is going towards, with a new informal working group, towards mainly the second part will be one of the main focus of this group, to find their solutions, international, how to deal with those requirements which are here in our region, but also in other regions might come in the next few years. And last but not least, another thing which we see from the regulatory perspective is the switch from type approval to market surveillance. So we see, similar with software, also with AI, that the static approach of type approval is shifting. So it's not such easy just to once type approve the vehicle and we are done. It goes similar to the software aspect, more towards market surveillance. So it's more a dynamic task for the regulators, but also for industry and so on, how to deal with those issues, with the questions, and with those systems which are currently today already in the vehicle, but will come more and more in the future. Thank you very much.
Now it's the turn of the type approval point of view. Shubham, please.
Thank you, Esposito, for the kind words. And
Good afternoon, everyone. Before I begin, I am Shubham from RDW, the Dutch Type Approval Authority, and I'm here to present our point of view on this very illustrious topic of AI. Before I jump into the content, I would like to introduce RDW a bit. We are a very significant institute in a Dutch mobility sphere, specifically in automotive sector. And we not only regulate the vehicles based on the legislation, but we also help making those legislations. And also we serve our purpose as a market surveillance and testing authority. Before I lay out the topic of the hour, I would like to go through some challenges which are introduced because of AI usage in the vehicle. The first challenge which we face right now is from a systems engineering point of view. The well-known concepts of schematic gap, uncertainty quantification, these all concepts make it really tough to quantify risk for such a kind of a probabilistic system. Secondly, the concept of bridging the gap between data and safety requirements. That is something which is still to be explored and brought to a much more harmonized manner. Second challenge which we face right now is essentially around the safety management system. Because of the significant impact of AI on the safety, the risk which are managed through safety management system, we are still yet to discover how AI management system interacts with those processes of safety management system. And similarly, we are also looking into how AI management system also interacts with cybersecurity management system. So all the management systems with which the industry and the regulatory bodies are dealing with, we need to expand its horizon to also include the processes with they handle the AI systems. Third challenge is, of course, not just a regulatory challenge, but it's a challenge which is shared by, I think, everybody who are developer of the system, who are validators of the system, which is the black box nature of the system, which is essentially looking into the explainability or opacity of the system. And there is significant work that needs to go into explainability to shed more light on the decisions made by the AI system, specifically when it is used in a safety critical functionality. Fourth challenge, which is a very big burden for a type approval authority, because we work for the society. We are answerable to them, and we are the gatekeepers of making sure that this kind of system does not overlook all the ethical challenges that come with it. So the concept of bias and fairness, that needs to be also translated into a safety requirement. And of course, the whole scenario-based assessment should also address the gaps of ethical concepts. Moving on to the relevant regulations which AI currently impacts. The first one being the cybersecurity regulation. Because it's a new enabling technology, it can also introduce new attack vectors into the system. And the current R155 is rather limited to go into that domain. And I think the regulators also need to look into those areas of newly introduced cyber threats. Second is, of course, AL case regulation, which gives precedent to different continuous learning algorithms, which, again, is a huge challenge in terms of self-learning or even just learning and deployed with a static model. So, and the current new regulation, which is the R7.1, the DCAS regulation, that brings into the concepts like driver monitoring system, where the driver should be in the loop because it's an assistive system. And that brings in the whole HMI challenges of usage of such a system, as also mentioned by Expedito in the introduction. And last but not the least, the EU Implementing Act 1426 on ADS. It is one of its kind because it also addresses the ethical aspect of such usage of AI. But then again, we need to explore how do we test them, how do we validate them, and how do we make sure that those requirements are met. Moving from challenges to opportunities, because the current regulatory framework is shifting towards an AI safety case or a safety case in general. That's a new way of looking at how developers justify their safety to the regulators. And the current safety case should also work towards including the requirements or the regulations which are required for introducing those checks and balances. So how do we look at it? Mainly two pillars. One is audit, and the second is assessment, just like the current open norm structure of the regulations. In audit, we, of course, audit the management system and all the processes from the OEMs or the industry. And in assessment, we actually look into how safe and secure the product or the vehicle type is. As part of audit, we have to look into the data aspect of it, because data in itself is a huge topic, and it is one of the main key source of errors in any kind of AI system. So we need to look into the data management style of the OEM and all the processes that are that the OEM is following to manage their data, not just training data, but also the validation data. And of course, with ISO 8800, we are also looking into the lifecycle management of AI. In the assessment part, what we are looking into is requirements around the system architecture. What are the requirements which the OEM developed their system based on, and are they sufficient, and are they comprehensive enough? And of course, that needs to be all tied up into a validation and verification plan. And we as authority need to make sure that that verification and validation plan is indeed comprehensive enough, and it is indeed justifying all the results or all the claims that the OEMs is making in terms of safety and security. To wrap it up, I'm proposing 4 key actionable points from an implementation point of view to transferring it to trustworthy AI, so that there is more acceptance in society of such a system. The first one is, of course, implementing AI Act. So all the requirements that are prescribed in the AI Act, I think that is a very good first step to generate more acceptability of such a system in the market and in the society. The second is, of course, harmonize on the requirement. And I think that is one of the main action points. And that is not something which we alone can work on. I think we need to work with many other stakeholders to harmonize on the requirements, and not just requirements, but also the definition of AI and how the industry or the developer looks at it. Third one is, of course, fostering more explainability. Because this is a new topic, we as the stakeholders should investigate more and should invest more on explainability. And we should take all the learnings that we can get from the CCAM projects on this topic and try to implement them in regulatory framework. And last but not the least is to ensure fairness and bias handling. We should get tangible reports or tangible evidences from the developers in their safety case that they are indeed handling the ethical aspects of fairness and bias in their system. That's it from me. Thank you very much.
Thank you, Shubham. And now it's the turn of the industry. Sarah, please.
Great to be here. I'm probably going to focus a little bit more on the opportunities and practical kind of promise of AI. So I think it's important to set the context. So there's not really a choice between having self-driving with AI and self-driving without AI. There will be artificial intelligence present in every self-driving system. The amount that a particular developer uses AI obviously differs, but the whole industry is moving towards using increasing amounts of AI. So hopefully a lot of you have had an opportunity also to experience a wave vehicle, or can still experience a wave vehicle, which is currently just outside the exhibition center. But at Wave, we are building artificial intelligence to solve the self-driving problem. And that's because autonomous driving is an AI problem. So the reason humans are mainly good at driving, some better than others, is because of our brains. We're really good at making decisions and lateral thinking. So we use our evidence that we've gathered from driving in different locations, and we apply that experience to new geographies and new road types. And so we don't need to be taught every single time how to drive down a road. Artificial intelligence offers the same opportunity. And that's important because despite many, many years of investment in the self-driving industry, around 15 to 20, and hundreds of billions being invested, I think we can all agree we do not have self-driving vehicles at scale. We certainly don't have many self-driving vehicles in Europe. And that is because of the challenge of variability of decision-making on our roads. But thankfully, we have artificial intelligence as a solution to that problem. So at Wave, we're developing the foundation model for driving intelligence. And as you can see on the left-hand side, we take inputs from a variety of different sensors. We're sensor agnostic, so we can take inputs from camera, radar, GPS, telematics. We can include LiDAR. And that essentially goes into the neural net, the Wave foundation model. And that gives us the outputs, which is the controls are, well, electrical signals are sent to the controls of the vehicle, and the vehicle can then drive. We can also have more kind of static outputs around perception, simulation, and something that's worth kind of drawing your attention to is the fact that even with a foundation model, if you input the same data inputs, you will get the same answer. So these foundation models are actually deterministic. And that's really important because it means when we have an incident, if we can re-simulate the incident, we will be able to look into what went wrong in that particular setting. And obviously, there's been a lot of focus on explainability, and I would encourage us to think more broadly around explainability. I think we can often think of it as a binary concept. It's either explainable or it's not. The reality is explainability should be thought of in different levels. So different people of different technical backgrounds will need different levels of information to understand if something is explainable. And that's not new. This isn't the first time a technology has needed to be explained, particularly complex technologies. And I think everyone in this room today probably uses technology and they don't know how it works. So I think we should think more broadly and be open-minded about explainability in the context of self-driving. So AI allows us to essentially build a system that can drive anywhere on any vehicle, and this is really important for building for scale. So the self-driving industry to date has been held back by scalability of solutions. So artificial intelligence allows us to drive we are operating out of around 4 different locations permanently, but right now we're actually driving across many states in the US, in Germany, Italy, obviously we've got the vehicles here today, in Switzerland, France, and Japan. And that's one AI model that's driving in all of those locations. And all of the data that's being collected from from those driving tests every day is being fed into the Wave foundation model. So that's essentially a bit like a human who can drive all over the world and experience all of the different road networks, types of road, driving on the left and on the right, and experiencing lots of different scenarios. So we're essentially creating a very intelligent driving model. So this is some data which shows how our model is essentially becoming smarter as it drives in different locations. So this compares our US driving performance to our UK benchmark. So we were founded in 2017 and began training on UK roads in 2018. And last year we moved to the US. And it took us 100 hours of US driving to see a 5 times improvement on our zero shot. And zero shot means if we started driving in the US without any previous training on US data. In 500 hours, we were able to see a 40 times improvement, reaching our UK benchmark. So that shows how quickly we can move from one geography to another. And that's the first time we've moved between 2 countries, and that's moving to the other side of the road. So that shows how quickly the artificial intelligence can learn. And as we move to each new geography, each new road type, we expect that number to significantly decrease. So that means we will have an artificial intelligence model that can move from country to country, be verified and validated for that country, and be deployed in all kinds of vehicles. And now, clicker's working. So we're testing across the US, UK, Germany, and Japan currently. And as you said, we have the vehicles outside, and I would love for everyone to come and experience them. I think one thing I'd love to kind of just sort of part on is, we don't have a choice around using artificial intelligence. And whilst, we very much understand kind of the concerns around how we verify and validate the technology, we have a lot of people working on that in Wave, and we really want to collaborate more on getting the word out that these systems are not a black box. We don't refer to them as a black box. And it's certainly not true to compare, an end-to-end system to a traditional system and call one completely intelligible and another a black box. All self-driving systems are incredibly complex, even if they use programmed rules in their planner. So actually, for the whole industry, we have the challenge of verifying and validating according to whatever underlying decision-making tool that we use. So I think let's try and discuss, how explainable we want these systems to be and for what purpose. And then we can have, I think, a more practical discussion around what information is useful to meet that objective. Thank you.
Thank you, Sarah. And then let's move to the European institution. Alvaro.
Okay, hello everyone. So I would want to start by thanking Expedido for organizing and chairing the session, and the taxonomic, regulatory and operational contributions of my colleagues before that have been a great introduction for this. So I'm coming from the European Commission, from the AI office. I'm focused on excellence programs. And I am here to tell you a little bit about the different initiatives that the Commission is doing and the input that we want to gather from you to ensure that the next regulatory actions and the shaping of the European ecosystem can serve for the benefit of all of us. So, on the 9th of April, the AI continent strategy was presented. It focuses on the building blocks that we need to ensure that we are deploying advanced AI in Europe. There is a strong focus here on computing infrastructure and the need to have the correct amount of data available and their ability to circulate both across borders and across actors to gather the minimum volumes that we need to be able to develop certain kinds of really frontier AI, right? The action plan also puts a lot of weight in having trusted algorithms with the Apply AI strategy behind it. And here what we want to do is increase the deployment of AI systems that can be claimed to be fully made in Europe, to strengthen and further develop the European ecosystem to keep ramping up, right? To complement all of these efforts, there will be further actions in terms of ensuring skilling up, as well as certain aspects of regulatory simplification that are coming. And essentially, what we're searching for here is to accelerate the path of the European ecosystem of AI and brisk innovation as quickly as we can. So, very briefly, one of the main pillars that we have here is on computer infrastructure. Here, the main action will be the AI factories, which will be running on the backbone of EuroHPC and will be adapted for the developments of AI development, right? What this is going to mean is and until now, HPC is based mostly on CPU, as has been CPU bound. Get the GPUs that we need in there, start training advanced AI. Then we have the AI Cloud and Development Act, in which we will be looking at boosting our capacity for cloud infrastructure. And lastly, the gigafactories, which look to really equip Europe with that massive exascale capacity that we need for frontier models. When it comes to data, I really want to mention the first entry over that side, the data labs that will come attached to the AI factories and will provide data services aiming to link the different European data spaces that already exist, and will act as data trustees to enable what I mentioned earlier in terms of data exchanges, right? Here we also want to ensure the development of the European cloud software and essentially minimize any unnecessary bureaucracy that has existed until now and be able that we can remove all of that and put the entire program at the serve of innovation. So regarding the Apply AI strategy that I mentioned before, is built on the back of several public consultations, the first of which was launched on the 9th of April and is open right now until the 9th of June. These kind of consultations, there will be more of them, and they will inform the structured dialogues that we're having internally, where we take inputs directly from experts. The first such structured dialogue on the technical level was very aptly focused on the automotive sector. It took place a few days ago on the 11th of April. And we had over 250 experts convene and discuss on a workshop focused on the current and emerging cases of AI, looking for opportunities, looking for challenges, looking for barriers, and seeing what are the best ways to get rid of them, right? So all of this activity will eventually feed into high-level structured dialogues, highest political level, with the commissaries and etc. And we expect that this way we can transfer the information that you, the practitioners, are having all of the challenges, all of the burdens, and we can move them all the way up the food chain and ensure that all of the next actions that are taken on a European level are to make life easy for innovation. Here, during this action, one of the things that kept coming across was the fragmentation of the European ecosystem, the limited access to data, the potentially overlapping regulations. So once again, going back to the regulatory simplification that I was mentioning earlier. And I would just want to invite all of you to look up these calls. Like, we are publicizing them as much as you want. We really want to hear your input. So please contribute and help us make it better. In parallel, of course, we're working with the member states and etc., but we really do have a special interest at this time to hear from the practitioners. So this entire initiative is actually running on something that was presented last year, the 2024 Innovation Package, where we put in motion a range of activities to fuel this development, right? As part of this initiative, 2 billion euro was mobilized for the AI factories and increase the amount of compute available. And on the other side, you can see an additional €500 million that is going to be used to create the latest tool. And this is generative AI mostly for key sectors. There are 14 sectors that are complained, and among them we have mobility, manufacturing and engineering, as well as robotics. That as you can see, they're very closely interlinked, and in reality, we don't want to consider these separately, as they will heavily influence each other when it comes to practice. So far, we've committed already over 700 million of the initial 500 that were budgeted, so we're doing great, and we're really exceeding the initial expectations for this process. But when it comes to mobility, 2025 hasn't been the most eventful year, right? Like, we haven't really put much out of there. So there is a strong focus for 2026 and 2027 to further develop our goals on this sector. And here's where I would like to, once again, and I think that for the third time now, really ask for your input. We really want to tailor this to the innovators and to the actions that are already going in Europe. So we would be delighted to hear your contribution. So, very briefly, the European and Connected and Automated Vehicle Alliance has launched this year in 2025, aiming to accelerate the development and deployment of connected and automated vehicles. They want to bring together industry, academia, and the public sector to work collaboratively on the biggest challenges that we have at the moment. And the way that they plan to achieve this is by making use of experimental testbed and regulatory sandboxes. So the entire compliance thing can be put aside for a little bit, and we can focus on getting the technology out there. in a controlled environment, right? This will go hand in hand with adjustments to the regulation and making easier the full deployment of autonomous vehicles, as well as the public invested that is coming from Horizon. These actions are based on the Automotive Action Plan, which is structured on 3 levels. On the first one, we just have pure hardware. We are aware of the current situation with chips in Europe and are working to solve this situation. Then we have platforms and software, and we have the applications and services that will be running on top of them. The automotive area of the Apply AI strategy is very much under development, right? Hence, all of these consultations that I keep referring to. We don't only aim to cover in-vehicle AI models, but also any systems that empower transportation, public mobility, anything that you think that at the moment can be a game changer. So, as I mentioned earlier, we ran our first workshop very recently. A series of others are coming. And if you're interested in contributing to this, there will be a further session tomorrow where 2 of my colleagues will be here, and I heavily encourage you to engage with them if you cannot find me. Now, to quickly finalize, like I've been saying over and over and over, your input is the most important thing that we can have at the moment to find these big use cases for the automotive sector and to define them correctly so the money is correctly allocated in the upcoming calls. Right? The ongoing public consultation is a brilliant opportunity to do this so that we can choose the strongest topics in 2026 and 2027. So I'll be very happy to be approached during the time that I have at the conference, which arguably is not very much. But still, please come, engage, and otherwise my email is there. Write to us directly. Let's start this dialogue and let's start this conversation. Thank you very much.
Thank you, Alvaro, and thank you to all the panelists. Now we will start with a question. I should start with a question to the panelists, but I think that will be important to try to establish a sort of common ground. And it means that I would like to start with a question to you, to the audience. If some of you would like maybe to provide me a definition of artificial intelligence, who is the brave that would like to give me an informal definition, but please, in the audience, there is someone that is so brave? Yeah, okay. If I can ask, there is yeah. If you can just introduce, yourself, name and affiliation, and then here.
Brave or naive, that's maybe very close together. But Christophe Rambat from Flemish Agency for Roads and Traffic. I'm involved with evaluating projects for CCAM services to be put on the road. I would define it starting as artificial intelligence is intelligence which does bring intelligence, but that is not authentic human intelligence.
Anyone else? Oh, yes. There.
Okay, thanks. So most people speak about artificial intelligence, but what we actually mean is machine learning. So maybe we need to ask for a definition of machine learning.
Yeah, thanks. To be honest, the reason why I was asking is because I think when we look to the literature, when we look, the different understanding, there are some people that think that is machine learning, other people that have a broader, think about what artificial intelligence is. I don't want to answer to this, but I would like now to ask also to our panelists, maybe a few of them, not all of them, because we already, are running late. But let me ask the same question to Zisis. I think you were also, introducing the concept in some way. Can you provide, your definition of artificial intelligence, mainly focusing on the CCAM? Yeah.
Thank you for the question. I had also part of inside my presentation. Artificial intelligence is the way forward if we go towards CCAM, to enable CCAM in a way, also as we heard from Wave, that the intelligence which is needed to achieve CCAM systems in the future, but also nowadays. So maybe this is towards CCAM maybe a good way forward for now.
May I ask also to Sarah, maybe from industry point of view, if you'd like to make your...
I agree with that definition. I'm not going to define artificial intelligence. That's just turned off. I mean, I think the easiest way to think about it is kind of the practical application. So I talked about how Wave is using a one neural network to power ADAS and AV technologies. And obviously there are lots of different types of artificial intelligence that go into creating that network, but I do think that's kind of the easiest way of thinking about it.
Yeah, thank you. I mean, this question was mainly also to make clear that we need to discuss also on the definition. We need to try to establish a common ground. I think what you were suggesting maybe can be a good approach, but we need to start to have, this discussion. Let me now start with the question. I will start with the first question that will be mainly to the member state. In different presentations, we have seen that artificial intelligence in some way is already there. So I would like to ask to you, to thesis first. In the current vehicles, how much, artificial intelligence is already influencing the safety and also the performance of the vehicles?
Yes, thanks once again. And as you mentioned, it's already in the vehicles. So we have also in part of type approval, we have requirements, functional requirements, performance requirements for different systems. And the use of AI is already there. If you go towards traffic sign recognition, for example, driver monitoring is a good part to detect objects. It's part of the regulations in a way, or of the requirements that AI is used to achieve the goals of the systems which are currently in place. So the safety of those systems rely in a certain way on the AI to work, to have a good achievement. Detection rate, for example, is one good metric, or also other metrics which are used to make those systems work in very different scenarios and situations. So it's already used and facilitated by many operators, manufacturers, and so on, to have AI, good AI for those systems, or good AI models in a way to say.
Thank you. My follow-up question will be, is sufficient, but we will wait for later. I would like to ask the same question also to the type approval representative, to Shubham.
I think from a regulatory point of view, we are looking at it not as an AI system, but we are looking at it from a vehicle system point of view. Of course, the performance of AI determines the vehicle's performance, but then we have to take a holistic kind of view and not just look into the performance of the AI system. Also it determines the performance of the vehicle. It determines how much the system is keeping the driver engaged for an ADAS or assistive system. Also in the entire infrastructural way, starting from traffic sign detection to perhaps when you mesh it with other enabling technologies like V2X, there is already many applications which we are seeing nowadays, but I think there will be a boom in the application in the upcoming years. And we, from a type of rule point of view, also need to address those, if not today, tomorrow.
Yeah, thank you, Shubham. I do believe that often when we discuss about artificial intelligence, we are always linking to a system that is an ADS, automatic driving system, that's fully automated. Then I would like now to move to Sarah, because Sarah, in your presentation, you were mentioning a foundational model, but also end-to-end. End-to-end for me means basically a single model that will handle the input from the sensor till basically the actuation. I think when we think about end-to-end model, often one of the things that I think was also in your presentation, we think as a black box system. So I would like to understand from you, how mature are, end-to-end system in order to be deployed, in the system. Maturity not only in terms of performance, but I would say also in terms of safety and also certificability of such system.
Yeah, so foundation models can be used for lots of applications. So there are many foundation models in existence today. I think a lot of people would probably mainly interact with them through kind of ChatGPT or LeChat, like these kinds of assistance tools that people are using. They're all powered by the same technology. So Wave's foundation model is essentially a foundation model that's being used in the automotive sector. So safety critical automotive application. That foundation model will be used for other purposes in future. So automotive is our first focus, and we chose that focus because we really think that what we refer to as embodied AI, so essentially means AI within a machine, within a physical machine, will be the next kind of frontier of artificial intelligence. And actually, once you train a foundation model to be able to drive on public roads at scale, complying with all of the relevant regulations, validated to an appropriate degree, actually, that's an incredibly powerful technology. And you can then deploy it in other sectors, which is really important. Well, it is really important why obviously we get the AI on the road in its current form, because actually you then create a very intelligent system that can be used in many places. If you think about kind of other transport use cases, but also manufacturing, health. So essentially what end-to-end means is that's actually that terminology really applies in the automotive sector, specifically around automated driving systems. So typically automated driving systems are, traditionally they were broken into modular robotic stacks where you would have machine learning responsible for your perception. And then you would have would be more programmed rules within your planner and your control system, which then sends your signals to your actuator. The reality is there's no automated driving system that is acting that simply anymore. It's a huge oversimplification to say that there are modular robotic stacks and there are now end-to-end. The reality is the industry is even moved past hybrid systems. There's a huge amount of artificial intelligence and prediction in every planner that's used in every automated driving system, which is also why it's not helpful to think of a black box and not a black box. Again, not the case. So every automated driving system has an incredibly complex decision making, whether it's end-to-end or not. End-to-end just means that you use one neural network for each of those modular, what would have been traditional modular stacks. So your perception system and your essentially your planner, so your decision-making system, are one neural network. So it presents new challenges, but ultimately it makes the system very powerful. So whilst I can understand kind of specific concerns around the interpretability of that system, it doesn't actually introduce any novel interpretability challenges versus an older programmed system, because the programming becomes so complex that it's very hard to interrogate the decision making. And the reason the industry is moving towards increasing amounts of artificial intelligence or fully end-to-end approaches, because it's certainly the case now that Wave is not the only company building end-to-end artificial intelligence. And anyone who experiences the performance will see why, because it's incredibly challenging to drive across upwards of 10 different countries with one stack. So, it's incredibly important that we find ways to talk about this technology, I guess, and we find like a better common language, I guess, because I think it's quite unhelpful if we just talk about black box. It's not really reflective of where the technology is at. We have a huge amount of introspection tools, and we call them introspection because that's essentially discussing the method rather than talking about explainability. Explainability is the outcome. So we use lots of different tools, and we would obviously work with type approval authorities to show those tools and to make sure that they were intelligible to the type approval authority, with the outcome being a sufficient amount of explainability according to the task.
Thank you for the answer. But I would like to stick to one concept and maybe ask the question also to the European institution, to Alvaro, but also to Alvaro as a researcher, I mean, what do you think, I mean, how mature are, I mean, end-to-end learning approach for real world driving?
You put me in a bit of a pickle, so I'm gonna have to wear two hats here. Okay, so from the Commission, end-to-end approaches are very impressive from some technology that is quickly maturing and still in its early stages, right? I believe that moving away from the traditional approach based on feature engineering, high amounts of mind power, et cetera, like, yeah, we want to get there, but it's going to take some time. The amount of legacy technology that is out there working on this, hey, we need to change all of the systems, right? So while the demonstrations are being certainly impressive, as anyone that has ridden in the car outside can see, and these end-to-end approaches allow for really complex behaviors to emerge, right? But really complex behaviors also imply really high demands for explainability, interpretability, and this is going to be key for the safety accreditations that we need for certification. Without this certification, we cannot go anywhere. So that's the end of me for the Commission. And now, as a scientist, many of these things work also on self-play or reinforcement learning, and because you need a lot of data to be available, these training processes are very data hungry, right? The moment that you introduce these kind of issues, these kind of approaches, you also introduce problems with it. If you introduce reinforcement learning, you have an environment, and the environment can be hacked. The reward can be hacked. And then I'm still on the wait, personally, again, personal hat on right now, I'm still waiting to see the trade-offs between the complexity that end-to-end learning removes versus some of the new complexity that is introduced, right? And how these two will balance out. Overall, I think that is an incredibly promising technology, but realistically, and this is an opinion, and it's my opinion until it changes, that getting to the full certification of these systems, as long as it's fully end-to-end, right? Camera to pedal, full policy as an output. That's going to be tricky. If instead we say that we are combining it with some form of, I don't know, drive-by-wire approach, right? In which we have the end-to-end learning, which is not the end because there is another system that comes afterwards. But then this fly-by-wire, which is the same that Airbus has been using this for a long time. This is a known technology, right? And you can define a safety envelope, and then you're only allowed to exert actions within your safety envelope. The game changes here for certification, because suddenly we're dealing with a kind of technology that we've already been familiar with, and especially in an extremely regulated area like aerospace. And then that can be a starting point to envision the next level of the next generation of regulation that needs to be present, and the next generation of tests that we require to make sure that these technologies can hit our streets as quickly as possible.
Thank you, Alvaro. I think you mentioned also an important thing, that sometimes we use end-to-end, but it's not just end-to-end. There is also, other maybe models or technology that will support, like safety envelope or whatever. This is why I would like just to jump back to Sarah.
Sorry, I had to come in on that because we do have a safety envelope. So just have to clarify that, Alvaro. I think it's also worth saying we're deeply involved in the UN type approval progression for L3 and L4. So I would like us to maybe think a bit more positively about how we're going to see end-to-end be certified. My team are actually really involved in representing industry in the drafting of level 3 and level 4 regulation, and we're constantly scanning for issues that might block end-to-end or any use of artificial intelligence, because obviously it's integral to the regulation and the success of the regulation that it's tech agnostic, right? So it shouldn't support any one technology approach. But I wanted to make sure that, I clarified that, WAVE is developing a whole safety assurance mechanism around the end-to-end artificial intelligence. We will have a safety subsystem that will actually act as a safety envelope which will sit alongside our end-to-end driving model. So I think potentially the technology is further along than we think it is. The technology is not in demonstration mode. We actually announced a partnership with Nissan a few weeks ago and are hoping to have our technology on Nissan vehicles by 2027. So it would be great to talk about the technology at the stage of development of where it's at. And it's definitely not just doing kind of short demonstrations. The vehicles are driving all day, all night in multiple countries, constantly learning, and are very close to production.
Yeah, thank you, Sarah, also for the clarification. I still think that when we discuss about end-to-end, one of the points that is always raised is about AI explainability. I would like to ask, to most of you, what are the current limitations in the AI explainability, how they can be addressed in the certification, and also whether we need, that the AI will be explainable, and for what reason. Let's start first with the type approval. I will say let's start with Shubham, please.
Explainability is one of the promised solution to all the questions or all the challenges that AI raises. But certainly there needs to be a significant amount of work that needs to go in from an academic point of view, from industry point of view. As Sarah has mentioned, that it's not a black box. Maybe her team has devised a way to put more explainability into it. But then that's just one company who has achieved it, per se. But then again, is it good enough to comply to the regulations or the safety requirements of those regulations? That is yet to be seen. And of course, with explainability, the developers benefit, the regulators benefit, general public benefit. So I see multi-dimensional benefits of investing and investigating on something like explainability of AI.
You would like also to complement, add something on that?
Yes, thank you. I basically agree. But I would also highlight, if you talk about explainability, we talk also always about complexity. So if you have complex systems, if you're going towards ADS, so to say, they are less explainable than easier systems. So this is, I think, very important information. If it's complex, it's more difficult to explain it than less complex. If you have more layers, you need more data, bigger models, and so on. And the second part towards explainability is how safety critical this is. So the more safety critical the model is, or the system, the AI system in the vehicle, the more it should go towards explainability. So if it's let's go to the brake, for example. If you have a brake algorithm which is AI driven, why to do so, I don't know, but let's assume there should be such way, it should be explainable for sure. So complexity and safety critical is always part of the explainability part.
And I would like to finish this round again with Sarah, because your technology is end-to-end. You say that there is also a safety envelope, but I think the problem about explainability is there. And I would like to also hear from you how you address this.
Yeah, I'm also interested to hear what the different reasons are for explainability. Like to the other panelists.
Shubham, I think you want to like to.
One thing that suddenly pops in my mind when you ask this question is essentially forensics of an accident. If we have some kind of explainability, then we can always come back and look what went wrong. Was the end-to-end to blame, or the safety envelope to blame, or the other road participant was to blame? Not just that, second one, as I mentioned, from a developer point of view, they can rigorously test more on the edge corner cases, which they can find through explainability, because they understand what the system thinks and why the system thinks so. So, yeah, that is my opinion.
So I think in the event of an incident, I can say very confidently that we will be able to explain what happened. So there's a huge amount of work that's going into in-service monitoring and reporting. When an incident happens, and if it is suspected to be at the fault of the system, the manufacturer will have to do, root cause analysis and use different methods depending on what their stack is made up of. And a lot of those methods will be specific to the stack. So it will depend if you're using end-to-end or another kind of approach. But I don't think end-to-end will throw up any kind of blockers, so to speak, in comparison to other systems. In terms of edge cases, I didn't quite follow the link between explainability and edge cases, but I would just say that artificial intelligence is the only technology that we have today that can actually handle edge cases without having to be trained on the edge case before it happens. And the very definition of an edge case is that it has a really low distribution, will be incredibly hard to experience in the real world. So it will be very difficult for any manufacturer who's not using artificial intelligence to be able to deal with an edge case. And that is exactly what makes systems dangerous. Artificial intelligence also gives us the opportunity to generate edge cases. So we have a world model called Gaia 2, which essentially creates synthetic edge cases because it has the ability to generate realistic driving scenarios. So that will be incredibly helpful for the industry, both for our development and if we ever, export that for general use, other developers will be able to use that to create an infinite number of edge cases. So actually, I would probably pose that artificial intelligence is the answer to edge cases rather than being a particular challenge.
Yeah, thank you, Sarah. I would like also to ask Alvaro if you'd like to say something, and then I would like then after that to give the floor to the audience for some questions.
Sorry, I clicked too quickly. Well, as someone who has extensively worked with neural networks and has programmed them and had to diagnose them, like explainability is one of the major issues that we have for certification, and I don't believe that at the moment we have a clear methodology that actually gives us explainability in anything neural network involved. There is a wealth of methods that have been produced, like 2018, I think, that we had the counterfactuals proposed, and those were very good for private situations, but that's the same as giving counterexamples and say, hey, in these situations it doesn't happen, so we can try to infer and diagnose. Let's not confuse diagnosis with explainability. Diagnosis is post-X, and is the explanation of how something came to be. Explainability needs to happen at inference, and it's just simply, hey, this is the input and that's the output, and that's what's happening inside exactly to map this input to that output. So, counterfactuals. We have neurosymbolic AI that has been 5 years away for more than 10 years. So, it looks great. The combination of modern AI with symbolic one, so it's completely interpretable, it doesn't work at the scale, at least not today. I really wish, and by this, not the European Union, it's the scientists talking right now. There are some efforts in mechanistic interpretability, but as far as I know, that's not complete right now. I'm not completely put on this. The closest thing that I've seen right now to a path to interpretability could be some of the activity that Anthropic is doing in terms of identifying cluster of neurons within frontier models, mapping them to certain Exactly. It's but it's the closest one, and it kind of can follow certain topics, and by on top of that, training models on top of the activations and on the identifications, you can kind of infer what's happening, but then you have another model intermediate, and what's happening on that model, right? So the problem with neural networks, which is a problem since their inception, is that architecturally, they're not well suited for direct interpretability. Together, we need to come up with a solution for this. It shouldn't, in other areas, in other jurisdictions, this is not necessarily getting in the way of innovation, right? But in the European Union, and imagine that I put it back on, we need to respect the individual rights and the rights of the individuals across, and that also means from the point of view of safety. So there needs to be certain guarantees beyond ex-post guarantees that we can understand what all of these systems are going to do. Or alternatively, have a set of these safety envelopes that we've been discussing until now that are clearly interpretable and are the last link in the chain, right? You can have the most advanced neural network taking the decisions, but at the end of the day, that comes to a system that translates those inputs into something that later can be easily explained and not just diagnosed after it's gone wrong.
Yeah, thank you, Alvaro. I think that your answer about the topic about explainability is triggering not only our panelists, but also, the audience. Then we are already, approaching the end, but I would like to give, some time for the audience. I will not be able, to ask all the questions that I was supposed to do, but at least let's give some time, to the audience for asking some questions. Yeah, okay. I would say let's start with Matteo, if it's not a problem. He was raising the hand already during the... Please,
thank
Matteo.
you, Spirito, first of all, to moderate this difficult panel, I must admit, and thank you for the panelists as well. I needed to take some notes because there are so many things that I want to ask, but I will try to summarize them in two macro areas. First of all, I just want to build on your point on explainability. So you mentioned, actually I agree with you, you mentioned about explainability is not diagnosing, and I agree with that. And I think we just need to look at explainability from an holistic perspective. Sarah mentioned about in-service monitoring reporting, safety management system, safety case, evidence. So there is a strong focus at the UN level and European level as well on processes. So the manufacturer will explain what machine learning techniques have been used, what is data governance, data bias, how these elements have been addressed. Plus, in the automotive world, we have event data recorder, data storage systems for automated driving. So I think I would invite you all to look at explainability from an holistic perspective, not diagnosing input and output, because obviously, foundational model do not help with that. And that would be the first point on explainability. The second one is on requirements. Is actually a clarification because I saw a couple of presentations from Germany and RDW initially mentioning about operationalization of requirements. I have the same struggle with you, like you, and requirements on architectures as well. I'm coming from I have a regulatory background, basically. I'm coming from, the other side, and now I'm working for, I didn't mention that, NVIDIA Corporation, and I deal with regulators on a daily basis. So regulations tend to be technology neutral, and to preserve that aim and objective, there are no prescriptive requirements at the architecture level, but there are performance requirements. So is your point focused on the fact that we need specific requirements on the actual architecture when we apply AI? For example, perception stack, we need to ensure a certain perception level, planning and control, whatever, and that, in that case, will hinder technological innovation because obviously end-to-end AI will not work as such. Or your point was, let's focus on basically the audit part, which is something that is happening also in the regulatory work because we don't need to look at end-to-end AI, but we can look also at steering equipment, for example. The current regulation has a strong focus on safety audit, where the manufacturer explains, what is the actual V process, like verification, validation, fault tree analysis, FMEAs, to basically build up a case and then explain to the authorities what and why that system is safe. Yeah, that would be my point. Are you actually looking at defining specific requirements? And in that case, we are, I guess, going against the principle of technology neutrality, or your focus is, as it is happening naturally in the development of the complex systems in the regulation, looking at a stronger process focus approach, where, for example, we capture the need for an additional V on data bias, data governance, and so on and so forth. Thank you so much.
Yeah, thank you, Matteo. I will ask, Zisis or Shubham to reply in 1 minute. We don't have enough time. And then I will ask also the other, that are going to make questions to be a little bit more concise with the question because we don't have a lot of time.
Yeah, I'll be very quick. It is never the intention to make prescriptive requirements on any kind of architecture, be it software architecture or system architecture. The intention was to integrate it with the concept of safety by design. So whatever choices the OEM or the industry made in developing the system, by putting some control strategies in there or safety mechanisms in there, why they chose to do that and how they think that this safety mechanism is good enough to prove safety by design. I think that is the intention with the architecture requirements.
If you want, but try to be really brief.
Thank you. I will be very brief. I would just answer to you on this question. I would say as specific requirements as possible. It's pretty easy. So if we need them, we will take them. If not, we are good to go with general requirements, for example.
Thank you. Let's move to the next. We can go to.
Okay, my name is Peter Schmitting. I'm working for Etico, and I'm not an AI specialist, I have to say. But I hear from Alvaro we are going to roll out programs in 27 or 28, you said calls, and that will be then give results in 2030 or 31 if the projects are over. Well, anyway, now my question is about this explainability. You talked a lot about that, but is it really so important? Because if Sarah can provide us, in the case of an incident, a diagnosis, isn't that enough for us? Because if human drivers drive, nobody asks about if they can explain why they did it.
Thank you. Alvaro, it was for you, then I will say. Please go.
It's for me and for an entire faculty of philosophy. This is a very, very, very complex question. But very briefly, and to be honest, probably after we're done with this, I will have another idea, and tomorrow I will be able to give you a much better answer. The difference here is that a neural network is something that matches incredibly high variability of outputs to a series of inputs, right? And the reason that they're so interesting is because normally those inputs grow combinatorically, right? Like you have it on several dimensions, and then they explode. So they are more than you could ever check by hand. That's why neural networks are interesting, because situations and systems that are so complex where it is simply impossible to check every single of those situations, what is the output for each one of them? Well, neural networks are brilliant at doing those approximations and getting very reasonable control outputs. Reasonable is not perfect, reasonable is not necessarily correct, but reasonable is reasonable. Now, one thing that can happen is that in that, we were talking about multiple dimensions of inputs. So all of that is parameterized in and sorry, I'm going to get technical, on a hyper surface that you have over there that you cannot measure. It might well be the case that your neural network makes, because they do, mistakes while learning, or simply one point is not very well defined. So for a given combination of inputs, the output is completely out of the range of anything that you could have expect. There is a spike on your hypersurface. So the behavior when you hit that specific combination of inputs is not something that can be a priori be known, right? So the reason that we need explainability is to be able to query and know if it was an error on the neural network, if there was an error on an associated system, and if there is an error, if the error originates from a not sufficiently trained or sufficiently trained but not exactly in this combination of inputs, neural network, then we need to launch the necessary actions to correct that. If you cannot identify that point, it's like you're sailing on a boat that has multiple pinholes, and you don't know which ones of them are above or below the flotation line. However, these pinholes haven't been pushed through yet. But one wave might come that could push right in the correct way, and suddenly you're sinking. It will
Yeah, thanks, Alvaro. I'm sorry. I don't know if just Sarah would like to intervene on that, because I think it's
I would just say that, we're talking about neural networks generally, and then we're talking about neural networks that have been validated and verified for use in automotive. And I think there's a bit of a problem in having this conversation cross purposes, because Alvaro, you're talking about neural networks in general without a safety subsystem and redundancy on the vehicle. So I would just say that that's not reflective of how we'll be integrating a neural network into a self-driving vehicle.
Yeah.
In connected and autonomous vehicle.
Sarah, I think we are going to continue maybe during the coffee break, but let me give, if it's possible, Yuli, just the opportunity to the last question. It's already, okay, yeah, there are so many, but probably during, yeah, she is already the mic, I mean, then.
Thank you.
It's not my choice.
Thank you for the rich discussion and the presentations. I have a question regarding the assessment and audits that you mentioned early in the presentation. We are all aware about its importance in the CCAM domain. However, you put also on the list or on the top of the regulations the R155 that mandates the risk assessment and which is required also in the type approval to have the risk assessment every 3 years. However, we are aware how dynamic is this environment. So also you mentioned that we need to move from static to dynamic, mainly in the first presentation. How can we make this dynamic? We know that for any software or AI upgrade, this has to be in a continuous manner. So how can we match between the regulation and dynamic risk assessment in this domain?
I will say let's go with the thesis. I think you also were mentioning something about the dynamic process then. Please, if you can answer this question.
Thank you very much. Also, thank you for the question. And I would say we are still learning. It's pretty easy. I mean, software started a new paradigm change in a way. So we are not typically just on the vehicle technology level. Software came from the computer science area more and more to the vehicle. And we saw what's happening with software. With, for example, 156, the regulation to software updates. This should also go towards AI, towards market surveillance, for example. So the capacities are traditionally at the vehicle sector linked to the type approval, and the capacities and also the focus will shift more and more to market surveillance in the way that there are more bigger teams in the type approval authorities, for example. Maybe on the regulatory perspective, if you talk about software or AI, we should focus more on the market surveillance part, which is more promising than the static check in the type approval world. So we are still developing there, but the idea is to have more focus, more criteria, also in regulation, also in standards, more and more focus as we shift towards the software world, or to the AI world, which is also linked to software.
Yeah, thank you, Cisis. I mean, I think there is also another aspect, if I may, and then I will give the floor to Sarah, that we don't need to forget, and I think was mentioned also by Matteo. In the new approach that we are using for the validation, we are introducing the in-service monitoring and reporting. This is also, I mean, I don't want to say this is a continuous validation, but it's a way, I mean, to evaluate the performance over the time. It's something that manufacturer will do, must do, and then we will have, I mean, a confirmation about how the system will work, I mean, during the operation. But Sarah, maybe you would like to say also.
I was just going to say the same thing. So in-service monitoring and reporting and data storage systems for self-driving are two really important pieces of the level 3 and level 4 UNEC type approval regulation, and they will basically form the process for the market surveillance.
Thanks. Maybe the last word to the type approval authority that will do this job.
Yeah, I think also the essence of the regulation R155 is also to start from a static point of view, but then keep it dynamic, because the subject of cybersecurity is such a field where the threat landscape keeps on changing, and the task of the developer is to keep monitoring that threat landscape. And I think the nature of the field itself makes it dynamic in nature. Thank you.
Yeah, thank you. Thank you, Shubham. I know that there are a lot of people that would like, to ask other questions. We can use, the coffee break. I think the panelists will be happy, to answer to other questions. I would like to ask just one last question to all of you, and please answer just with one sentence. What is for you the most important step that we need to take to ensure, a trustworthy AI for enabling the deployment of a CCAM system? Would like to take first, this question. Sarah, please.
Harmonized regulation.
This is...
Yes, I would agree also on harmonization, but also to keep the focus on good AI, because not all AI is the same, not all models are the same. Some have more layers of security or explainability, to focus to get good, not any AI, but good AI in the vehicle.
I think harmonized requirements are, of course, that was also my answer, but then just to add on that is to not overlook the ethical aspect of it to the society. Oops.
Last word.
In one sentence, a shared and transparent validation and audit framework that works on absolutely every single driving stack. One open test bench, common scenarios, common metrics, and results that can be read in natural language. This is what's going to enable, from my point of view, transparent innovation. Now, we cannot do this in a vacuum. So please contribute to the calls from the European Union and our data gathering process so that this can happen.
Yeah, thank you, Alvaro. You spent more time than I was expected. I would like to thank, first of all, the panelists. So if we can give to them a big round of applause. And then let me thank also you for the active participation. I think that they will be available for you for other questions. Thanks so much.